Dear students, welcome to the class. As an extension of the population forecasting methods, we would study today the incremental increase method. It is just the extension of the arithmetic increase method, wherein we would also calculate the average of the incremental increase, right? This is the basic formula which is used for calculating the population after n decades. Now, Pn signifies the population after n decades. P0 is the population of the last decade known. X bar is the average increase of population. Y bar is the average of incremental increase, right? So to understand this in a more comfortable way, we would take up an example of this particular method, right? Now we have taken the example of say 1930. Here population, increase in population, and then we will take incremental increase. We will take the example which we were usually taking 1930, 1940, 1950, 1960, and 1970. The population was 25,000 and the population was 28,000. Population was 34,000. The population was 42,000 and the population was 47,000, right? Now what was the increase? Plus 3,000. X bar would be right. We had calculated the X bar in the arithmetic increase method. Now in this incremental increase method, we would calculate the incremental increase, the increase over the increase. Now this is what? It has increased. The increase, the difference between the two subsequent increases was plus 3,000. Now what is this? Now it has decreased. So you would put in a sign of minus. Now what will be your X bar? X bar would be plus 2,000. And there are three values. So you will take it as 667, right? Approximately. Now, your formula says what was your population? Now, if I need to calculate the population in this decade, the answer would be, now what will be the value of n? N would be 1. 1 into 2 by 2, it is again 1 y bar. The population in 1970 was 47,000. What was X bar? X bar was 5,500 into 1 plus 1 into 667. So what would be your answer? Would be 53167, right? Now, again, If you're required to calculate the population of, say, year 2000, it would be the population of 1970 plus 3x bar plus 3, 3 plus 1 by 2 into y bar. Now, this is 47,000. 3 into 5500. This is 4 by 2, this is 6, right? Into 667. So your answer would be 67502. This is the way we go ahead with the incremental increase method, right? Now, let us take another example for this method. Say year population, right? 1880, 1890, 1900, 1910, 1920, 1930, and 1940. The population was, say, 25,000. The population is 27,500. It is 34,100. It is 41,500. Then it is, say, 47,050. This is 54,500. This is 61,000, right? So the first step would be to calculate the increase. What is it? 2,500 plus. What about this? It would be plus 7400. It would be plus 5,500. 7450. 6500. Now we would calculate the increment over increase, right? Now what is this? 4100 with a sign of plus, right? Then this would have the sign of plus 800. Now mind you, it has decreased. So the sign would be negative. Negative of what? 1900, right? It has increased. The sign would be, this would be 1850. I'm sorry. Now what would be this? It would be 50 with a plus sign. Now this has decreased, so the decrease would be minus 950. This would be 7,400, 74,000, 5,500. This is 1,900, I suppose. Yes. So you calculate delta y. Delta y would come out to whatever be the value. Then using this formula, we calculate the population for any decade, right? We take up another example of this particular method, and mm, let us take this example. Population, take year, and you take population here. Increase would be 4,000, 5,000. What would this be? 5,500. Now this would be 6,500. This would be 8,500. Now what about this one? This would be 9,500. This would be exactly 10,000. And this would be 9,500. Increment over increase plus 1,000. Now x bar works out to 58,500 divided by how many values? 8. You get to a value of 731, right? What about y bar? Y bar would be 5,500 by 7. It has to be one less because it is increment over increment. Increment over increase. You get to a value of plus 786 approximately. Now, if someone asks me the value of population in year 1980, it will be 1960 plus twice x bar plus this would come out to 83484 approximately, right? So this was your uh, incremental increase method. Now we would take up, we have already taken up the simple graphical method. Now we would take up the master plan or the zoning method, right? Now, the approach towards this method is very simple. The city whose population has to be forecasted is divided into various zones. Suppose this is an arbitrary area of a city. Now, the zones are broken up. Number of residences in each zone is calculated, and say zone 1 has 2000 residents, zone 2 has 3000, zone 3 has 2500, zone 4 has 2500. This amounts to 10,000. Now, 10,000 residences. Say each residence has 5 occupants, 5 inhabitants. So the population would be 3,000, right? This is the way to estimate the population by this method. Now, the problem comes how to forecast. It is very easy to forecast the population because as the city expands, suppose the city expands this way. So this is say X, this is Y, this is Z. These three areas are being expanded and the proper plotting is done. The number of households are divided, are calculated, and as per the thumb rule, you multiply the average number of inhabitants and you get the expected population after this area is developed. So this is a very simple approach of solving uh, in fact, forecasting the population by master plan method or zoning method, right? Now we come to another method, the method that is ratio method. Now what is ratio method? In this method of forecasting future population of a city or a town, the city's census population record is expressed as a percentage population of the whole country. In order to do so, the local population, this country's population for the last certain decades uh, is calculated. 4 to 5 decades, the data is obtained by the census records. The ratio of local population to national population are worked out for these decades. The ratio is being worked out. A graph is then plotted between time and these ratios, right? Listen, like take for example, city Lucknow, right? Year, say 1960, 1970, 1980, 1990, 2000, right? Say the population was 100 and this say the population was 50,000. Say the population was 200, say the population was 70,000. Population was 350, the population was 1 lakh. 500, say 1,25,000. Then say 750, the population was 175. Say the population was 1000, the population was 1,90,000. Right? You obtain the ratio. Now, you can take it Lucknow by India or you can take it as India by Lucknow. The ratio would be 100 by 50,000, then 200 by 70,000, 350 by 1 lakh, 500 by 12500, 750 by 175,000, 1000 by 19. Say this is value is A, this is B, this is C, this is D, this is E, and this is F. Right? A graph is plotted between these ratios and time. Let it be A, B, C, D, E, and say F. Now, the years were from 1960 to 2010. 60, 70, 80, 90, 2000, 2010. You plot a graph, right? Now, if I am being asked to find out the population in the year 2020, what would I do? I would simply extend the graph and I would find out this value. This would give me the ratio and say this ratio is G, right? So this was population of Lucknow by population of India. This ratio is G. We know this. Now the population of India can be ascertained from the census division, which predicts the population growth of India. Right? Once you know this, so P Lucknow would be equal to G into population of India. Now this is a very simple method of forecasting the population of a particular city because it is being taken in the form of ratio with respect to the population of the country, right? So class today we have learned three easy and important methods of forecasting the population, and the methods I would like to repeat to the class once again. It was the first method was incremental increase method with this formula, easy formula, where Pn is the population after n decades, x bar is the average increase of population, y bar is the average of the incremental increase, right? We took up the example which we were taking for the other methods as well, and we worked out that x bar was 5500 and y bar was 667. Then we place the value of x bar and y bar in the formula, and we calculated the population of P1980. Right? Suppose the population of 2000 was required, so there would have in the space of 3 decades to be place the value of n equals to 3. Nothing else changes. X bar would remain just the same, y bar would remain just the same. Right? We had taken another example of the same method, incremental increase method, for year 1880 till 1940, and the process was just the same. The increase was calculated as we are generally calculate for the arithmetic increase method, and the increment over increase was calculated, and we found out the value of y bar, right? Then the values were placed, and for any decade, depending upon the number of decades, future decades, the value of n code can be placed, and the population can be worked out. We have taken another example for this method, and we worked out the population for the year 1980 when the population of 1960 was given. So the value of n would be 2, right? Look, students, the only problem which you can face in this easy method is that you can be just confident about working it out very quickly and making silly mistakes in the signs, either plus or minus. Like you see, this is minus 500, this is plus 500. So you need to be very cautious about placing the signs, right? Done? If you're cautious enough, this is a very simple approach towards forecasting the population, right? Then we took up master plan method, and master plan method says uh, that the city has been divided into several residences, several zones, and the zone wise the number of residences are being calculated, and taking a thumb rule of say 5 individuals in a particular residence, we can calculate the present population. Like the present population for the city is 50,000, which includes zone 1, 2, 3, and 4. But if this city is to be expanded further in 3 more zones, say X, Y, Z, with the area demarcated as shown in the figure, then each area is to be taken separately, right? And the number of residences need to be calculated, because if the plotting is being done, then it can be clearly calculated the number of plots cut from this particular area, and the again the total number of residences when calculated, the thumb rule is multiplied by 4 or 5 so as to calculate the future population when this area is fully developed. So we can always go in for the uh, plan the water treatment activities, water supply activities. Maybe a new water treatment plant has to come up to cater these areas. So this is all depends upon the forecasting. right? Then the last method was ratio method or the apportionment method, wherein took up an example of city Lucknow. Say for year 1960, the population of Lucknow was 100 individuals and the population of India was 50,000. Say, and in 1970, 80, 1990, 2000, and 2010, we have taken the data of population of Lucknow in India from the census department. We calculated the ratio of population of Lucknow to population of India this way, and suppose these values were A, B, C, D, E, and F. A simple graph is being plotted towards with the ratio and time. Time on the x-axis say and ratio on the y-axis. For different decades, the known ratio is being plotted. And suppose the population for year 2020 is to be calculated for city Lucknow, then this graph is extended and the value is calculated here. What would be the ratio? Say the ratio is G. Now P Lucknow by P India is, P Lucknow means population of Lucknow to population of India is G. Population of India can be ascertained by the census department, which when keeps the record of all the states and cities and predicts the future population of the country. So the population of Lucknow can be calculated, right? I hope you have understood all these three methods. Just go home and practice and come up with any doubts, if any, right? Thank you so much.